So my name is Rainer Wanscher. I'm heading the RF and Satcom Systems department at Fraunhofer IIS, and I'm also in charge of the satellite communication systems business field. Yeah, I compiled a little bit what we are doing in the frame of 5G, 6G, more or less. So why 6G NTN at our institute? Clearly, the obvious thing, it's an exciting story, so let's start with it. The other thing is that we want to bring these 6G functionalities everywhere. That's one of the main driver to work on these kind of things, and we want to introduce the NTN functionalities to support applications also in remote areas, even for automotive. Even because sometimes the automotive market is a little bit difficult, and also to install antennas on cars is not the easy issue. Enable the usage of satellites and also the layers in between, HABs. And we want to demonstrate first implementations and also support our potential customers in figuring out what is really working and how this can be done, and having test beds in the field and also in the lab. So one first view, I'm from the Division of Communication Systems, so maybe I skip Fraunhofer IIS is now, how old? Yeah, a little bit more than almost 30 years now, with a lot of employees distributed over several locations, and there's about 7 divisions inside. I'm from the Division of Communication Systems, so we are dealing with these 6 main topics. The NTN, 5G, 6G is more or less located within satellite communication and also mobile broadband communication. So we do this vehicular car-to-car communication type of things, and also the integration of satellites into 5G and 6G. And there we are very heavily involved in also in the standardization bodies. So with satellite communications, we started more or less within DVB S2, S2X with a special waveform, more dealing with beam hopping approaches. So an extension of S2X, and then within 5G, we went into this into the 3GPP standardization body, so really having people being there. That also sometimes has the disadvantage that also industry gets known of these people, and now they change to industry, but that's also, let's say, one of the basic principles of Fraunhofer, to educate the people and then let them go to industry and have industry doing good things. So this 3GPP or this 5G was initiated with an internal program first, and then we also got the ESA funding within the ALEX program, such that we could follow on and focus also on the NTN implementations in 3GPP. So what we are doing is, one thing is we have the ability to implement the new waveform capabilities and all these kind of things into open air interface, as well on the UE side, as also on the G03 side. With that, we can fastly deploy and demonstrate if things are working. So it could be either in the lab, so using a channel emulator, or also over the air or with terrestrial links. So live over satellite also has been demonstrated, as you can see here. So from lab to satellite, so pre-release 17 G0B, and we also did some demonstrations on 5G NTN over satellite, one together with Andreas, and also with different types of antennas, and yeah, and currently there's also some GeoKA band trials with Inmarsat, and yeah. So bringing and demonstrating the things, bringing into operation and demonstrating the things is a key issue for our work. Yeah, so I skip this. Where we have been involved, and is now, let's say, the timeline of 3GPP. Now release 18 is specified. So 5G specification for satellite is ready. All the things are set. Now people can develop the different terminals, chipsets, all these kind of things. There we have had a lot of work within that. And now it's ongoing in release 19. There will be additional things also targeting somehow this, let's say, 3D networks with the different platforms from satellite to airborne and ground-based platforms, and targeting energy efficiency within the system. All what has been said on AI, ML, all these kind of things now also have some input into release 19 and how this can be done. Yeah. So more our vision in 6G. So 6G as it does not really these, let's say, these hard breaks in the generations. It's always going from release to release, and once you decide that the release is called now 6G, and you decided when it's called 5G, but it's a stepwise approach. But let's say in the evaluation, so starting from 2030, now we are in 2022, so it takes some time really to bring it into operation and to define everything. And going to standardization is also, let's say, a lot of work. Going there, bringing in the ideas, writing and documents. So starting with normally with study items where you can bring in the first ideas, then if this is okay, it will be elaborated to a work item, and after that you could establish a T-doc, and this then runs into the real standardization. And our goal was to have our ideas brought into that with this approach, so also doing some patenting and these kind of things, and then having also, let's say, some flow back of money if things can be patented and are also standard essential patents. That's the main and the hardest thing to get really standard relevant patents. Yeah, so the 6G use cases in principle. What we are, you can see it's almost everything. So people call it network of networks, making everything possible, swarms of robots, automated driving. So industry automation, so very low latencies again, high data rates, all this AI as a service, sustainable networks. That's maybe something which is getting more and more importance now, to bring also the, let's say, the power consumptions of the networks down, and also including the user equipment, so such that we can more efficiently operate within these systems. Also drops costs for the network operators. And the main candidate technologies which are discussed here. So flexible network architecture, really setting up different nodes within the network, switching them on and off, and configuring this. Then the network itself could act as a sensor, so what's out there. So hybrid networks, clearly, terrestrial, non-terrestrial, 3D, additional nodes, green communications, sustainability, a very, very interesting approach. New access technologies, maybe also changing a little bit more the waveform, which is currently used, and also brought into the hybrid networks, and then all this edge distributed computation, AI, ML enabled networking. So that's where we are working on in different projects. So AI enabling. So we have like 3 projects there. One is Bavarian funded, the DSAI. So bringing it has as well as let's say communication system aspects inside, but there's also some with our audio guys, for example, bringing AI to also audio coding technologies. We are more focusing in DSAI on spectrum usage, interference detection kind of things. Then 5G Autosat KI, that's a larger German-funded project connecting the car and also adding additional artificial intelligence to properly connect the car. 6G Sentinel, that's an internal funded Fraunhofer project, also bringing AI together with, but also establishing new waveforms within 6G for this kind of approach. So, as said, there's several standardization activities in FreeGPP, ORAN, NGMN, ETSI, with what we intend to do inside the AI. And the connection to the system is taking the ORAN approach and figuring out what the interfaces are and properly attached to the right interfaces such that it can later be a little bit more easy integrated. And then in RAN, handover management, power control, interference management, channel estimation, maybe power saving issues. In the core clearly resource allocation, one of the, let's say, the basic AI approaches one would choose to do. And then, network automation, in future zero-touching networks, self-organization of the network, and that in essence, at the end, the human does not need to interact too often with the network. On hybrid networks, that's one of the other parts we are very much involved in with also almost the same projects. Additionally, the 6G Sky Celtic Next project, where we do a lot of work within that thing, trying to attach the hubs and get the connection to the hubs within the hybrid networks. These then connecting to the ground or connecting base stations or even connecting aeroplanes, focusing on the, let's say, on the individual links, doing system level simulations, figuring out what is the overall throughput of such systems, what could be the interference situation within these systems, because that's has to be properly managed within the system. If everything is transmitting and maybe even on the same frequency, this can really lead to tough stories then. And cost-efficient pervasive coverage, providing the data rate and the connectivity also for new use cases. We discussed a lot of use cases, for example, in the ESA 5G infrastructure study. I think it was like 70 or 80 different use cases for almost everything where you could think of that 5G could play a role. So from maritime applications to automotive applications, train applications, governmental applications, security applications. So many with a large set of different requirements, which then could also be used to define the satellite system, how such a satellite system could look like, which functionalities need to be on the satellite, and how the functionalities in the network have to be distributed also to the satellites. And then connecting the heterogeneous devices with quite also different requirements in terms of bandwidths, data rates. Going also from the UE to fixed and mobile UEs, and also the base station in this approach may also be mobile somehow if you attach it to a HAPS, if the HAP, or to a UAV. So if the high altitude platform is not a balloon or a blimp or something, but an airplane, so it's already flying around, always around the same position, but still moving. And then it could also lead to IoT devices with very low data rates and different requirements than all these mobile broadband things. And the challenges are mobility management, the traffic steering between the different system elements, channel modeling, energy model, and also to establish an energy model which tells you which part of the system, so which node consumes how much energy to optimize it on a system level somehow. That's to bring the energy down which is needed within the system. Yes, I think I'm fast. That's it almost. So that's again a list of the different projects we have there. Also some within the BF 6G platform, where we focus on this network energy saving also. In the 6G RIG, which goes more in new waveforms for TN and NTN and combining them properly. Within our system level simulations, we first do a link level abstraction, so defining the link, figuring out how the link behaves, and then introduce this into the system level simulations. Yes, and we were also part in a Wiley book called Shaping Future 6G Networks, where we were responsible for the chapter of NTN in 6G. So if you have the chance to read this, you're very much invited. And to announce an additional event, we are also within a Bavarian-funded project called 5G Bavaria. There's by the end of September, so on the 29th of September, there's a large event in our, let's say, automotive test, no, not in the automotive, industrial test bed, which is in our premise in Nuremberg, in a large demonstration hall. So just look at our website under events if you are interested. You are very much invited to join this event. There are several of these things are shown. Also, there will be some system level simulation demonstrations. So feel invited to join us there. And thanks for that. So main contact points with this regard is Thomas Hein, group leader and business field manager of this mobile broadband things, and myself. So thanks a lot. If there's any questions, I'm happy to answer them, not to ask.